decimate the industry. We also unfortunately have hurricanes, which we have no control over. And if you look at the graph on the right, you'll see that every year we have a hurricane. In 2017 we had Hurricane Irma. In 2021 we had 2022 we had Hurricane Ian. Every time we have a hurricane, our food production goes down. It comes up again, but the production is never going to be what it was before we had such a scale, unfortunately. So our citrus improvement program consists of these folks, Dr. Fred Demeter and Dr. Jude Grosser. They have been working at the Citrus Research Center at primarily as citrus breeders and genomics for over 40 years now. And I'm the relatively newer addition to the team. So we leverage all kinds of breeding and genomics tools, which Dr. Demeter is a world leader on, and bioconversion tools, which we look into to develop sources of genetic variation. Once we have identified sources of genetic variation, we develop newer varieties, we screen them, and we hand over to our colleague, Dr. John Chater, who's our horticulturist looking at variety evaluation. Once a variety has been evaluated and deemed for release, we get it released. So it's a very simple pipeline. You know, in the past, if you read any of the citrus genetics books, and even now, you'll see that most books talk about 4 ancestral species of citrus. But now we know from genome sequencing data that there are more progenitor species. And so this recent paper identifies 10 progenitor species in which there is no integration, genetic integration from other cultivars. So these 10 species are pure species of citrus. And you know, this is very important to also realize that because of these 10 species, we also have a lot of genetic variation in these 10 species. And citrus is very interesting in that citrus, if the chromosome numbers are the same in the species, they are able to hybridize with each other at a very easy rate. So you can actually cross any citrus species with any other citrus species and get viable hybrids. So it's much easier for citrus to improve using the species that we have. So in our program, we have been looking at those. I showed the photograph earlier of our 2 earlier breeders, Jude Grosser and Fred Demeter. They are more involved in conventional sweet orange and mandarin improvement. I am looking at the future. So I am looking at how can we, in Florida and elsewhere, help sustain the industry for the next 50, 100 years, and utilizing genetic diversity. So many of you may not know all these species, but these are species that we are using in our breeding program with a focus on 2 important species, Citrus australasica and Citrus latipes. We are also using these cultivars to develop niche specialty cultivars for the market. So a lot of work is being done to progress the genetics of these cultivars into conventional citrus. It's a long-term project because wild citrus varieties also have some negative traits. And these negative traits are also introgressed into the subsequent F1 generation. But from a long-term breeding perspective, we can actually do subsequent backcrossing to take out most of the negative traits. It takes time. This is one of my favorite cultivars. This is the Citrus latipes. It's the Kasikokel. And it's very near and dear to me because I'm from Meghalaya. So I grew up in Shillong. And Citrus latipes, I have seen, when I was young, I didn't know what Citrus latipes was. And we used to go out in the forest and we would see this envelope. And Citrus latipes has evolved in the Northeast, where there is endemic HIV, to be tolerant of this disease. And we are actively utilizing the genetics of Citrus latipes to create more resilient citrus varieties. One of the examples that I'm going to present, because of lack of time here, is cross were made between Citrus latifas and a very tolerant Citrus pomelo variety. And you can see here, this is how the leaf looks like in pomelo latifas and 3 of these hybrids. The interesting aspect is, when you test these hybrids as rootstocks in the field, in many of these hybrids, you are not able to detect citrus greening disease. And we have had several of these hybrids in the field for over 8 years now, and many of them are clean. They don't have the disease, which shows that Citrus latifas is able to transfer its disease tolerance trait into its subsequent progeny, which is a huge deal for us. If you look at a principal component analysis, and I'm not going to discuss in detail this, but you see that when you cross Citrus latifas with pomelo, you get hybrids that have traits, that have characteristics that are unique, and they cluster separately from the parents, which means that there is a good amount of genetic admixture going on that is resulting in the formation of new and unique hybrids. The second cultivar that I'm going to talk about is Australian limes, and I'm not going to talk much in detail. Chandrika here is the expert on Australian limes, and I'm sure she will talk more about it. But we have also been using Australian limes in our breeding program. Australian limes are HIV resistant in the field, plain and simple. You can grow Australian limes for years and years and years. We have 30-40-year-old Australian lime trees in endemic HIV environments, and then we never get the disease. They are absolutely resistant. You can utilize its genetics to develop new varieties. Our citrus improvement pipeline is very simple. You make hybrids with citrus and Australian lime. You evaluate the F1 hybrids. You do genetic analysis. You plant them out in the field. If they're disease susceptible, you discard them. If they're disease tolerant, they can be used as novel cultivars. They can be used as interstocks, or they can be used as pre-breeding populations to develop the next generation of hybrids. Again, all that I'm talking about has one common core concept: to develop strong breeding populations for sustainable citriculture. This is an interesting, I put in a few photographs and some diversity of Australian lime hybrids developed. All these are HIV tolerant. And added advantage is some Australian limes are very precocious. As a plant breeder, you need to have rapid selection of your cultivars. And most hybrids take 7 to 9 years to flower and fruit. Australian limes, some of them can fruit in 3 years and can transmit that precocity to its progeny. So you're able to get you're rapidly able to evaluate and get multiple generations within a much shorter time than was done. 2 varieties we have released. These are what we call finger limes. And the first one is Bear Sunlime and Bear Field Lime. We released these varieties 2 years back, and there has been a good interest in the niche market. It's used mainly as a garnish and in alcohol drinks. If you don't drink alcohol, you don't want it. The key advantage is they're HIV tolerant, extremely tolerant to HIV. They're very low maintenance. Research indicates that they really don't require much nutrition. And there's a lot of producers that are interested in growing this from an organic perspective. These also maintain anthocyanins in the hot and humid environment. Anthocyanins, if you look at anthocyanins in blood oranges, they're only in use after doses. These cultivars maintain anthocyanin even under heat, which is a huge advantage from the visual perspective. Before I finish this one little section, I'd like you to show some other varieties that have been recently released from our program. Dr. Dimita's program has released 2 mandarins and a grapefruit hybrid. This grapefruit hybrid has low furanocoumarins, which is more suitable for people who take medications. So it doesn't interact with medications. Dr. Brosso's program has released 2 many hybrids, but 2 important ones, 2 important sweet oranges, which are HIV tolerant, and a pomelo, which we have extensively used in our breeding program, which is also very HIV tolerant. So breeding program to understand and develop resilient citrus gardens for the next generation. Now, moving on. I talked about conventional plant breeding in general, but my core background is in genetic transformation, in genetic improvement. And I'll spend a few slides on what we are doing for the genetic improvement of citrus. So you can either use transgenics, or you can insert or delete a single or few traits into existing commercial varieties. And we have done an extensive amount of work to look at many different traits that can either be incorporated into citrus or removed for citrus to take care of certain specific issues that we're facing. When you look at transgenics, you potentially there is no change in the existing desirable characteristics of a variety. I kept the word potentially in red because we do, in rare cases, we do see changes, but it's very rare. And it somewhat circumvents the problems that we have in conventional breeding. That means we don't have all these off characteristics in the next generation. For the genetic transformation of citrus, and our group is able to utilize all these methods to efficiently transform citrus. Each one of these transformation methods has their pros and cons. So, what are we doing? We identify genes to put them in our and grapefruits and rootstocks. We screen them. Our strategy is to screen them in the greenhouse, in our greenhouse or with a commercial partner, and concurrently secondary screen of trees for HMB tolerance in the field. Because the key take-home message from years and years of working with genetic transformation and other models is that in many cases, greenhouse results do not transform into field results. We have seen in many cases that trees that are susceptible in the greenhouse are tolerant in the field. Trees that are resistant in the greenhouse for some reason are susceptible in the field. So, it's always good to correlate what's going on and have concurrent selection of your transgenic lines or any other lines in both greenhouse and in the field. Systemic acquired resistance is the pathway that we're working on for development of transgenics and CRISPR. And basically it's to enhance the immunity of the plant. So, in humans, every minute of the day we inhale bacteria, we inhale viruses, we inhale funguses outside in the roads, wherever. But we don't get sick all the time. We don't get sick because, we have several lines of defense in our body, including the white blood cells that help us provide immunity. It's only when bacteria, like the COVID virus, for example, are able to beat this immunity, that's when we get the disease. So in the plant, it's kind of similar. So when a bacteria or a fungus infects the plant produces protein molecules to actually immunize the tree and make it more resilient. And this is the trait that we are exploiting because we have identified several genes that, when overexpressed in a plant, can potentially provide durable resistance to that plant. This is an example of a field trial that we have, and you can see very quickly in some parts of Florida, well, I would say in most parts of peninsular Florida, we have 100% citrus greening infection. So almost every tree is infected with HLV. And so when you do field trials, within a few weeks, you're able to find out, a few months, you're able to find out what your trees are, which are resistant, which are susceptible. And here you can see immediately HLV resistant trees pop out.
So we published a paper in 2015, and actually this is the first study anywhere of transgene-mediated protection against HLB in citrus, in which we showed that the Arabidopsis NPR1 can protect trees against HLB. We have a lot of genes are upregulated, a lot of disease-resistant genes, a lot of salicylic acid pathway-related genes are upregulated when you overexpress NPR1, which indicates that the defense mechanism is well and active in the plant. We also recently published another paper using a tobacco gene, a salicylic acid binding protein to tobacco gene, which also provides durable resistance in the field. We also do some other fun stuff, not just HLB work. We're also doing a lot of work on citrus biofortification. And our study on citrus biofortification started by trying to understand if overexpressing anthocyanin in shoot tips can deter Asian citrus psyllids from feeding. Because we noticed that the Asian citrus psyllids, and the entomologists can vouch for that the Asian citrus psyllids move on visual cues, and they were not attracted to young flush that were purple in color, as you can see in some lemons, for example, or in some of the Australian limes. And so that was our theory. We started working on it. We wanted to see if we could actually deter the Asian citrus psyllid in engineered plants. But we actually ended up with much, much more. We ended up with beautiful transgenic sweet oranges, and this is actually a lime, the regular lime that is overexpressed with anthocyanin genes, VV MyBay1 from the grapes, and citrus-derived gene called ruby, which gives the red color in blood oranges. We also have done a bunch of work with early flowering, in which we have shown that you can transform a citrus plant and reduce its juvenility from 7 years to 18 months. And doing that, also we have proven that in select lines, you can actually bud juvenile tissue onto transgenic lines that have this gene and allow that juvenile tissue to flower and fruit within 6 months. Very important, which means that the protein that we are producing in the rootstock is actively being translocated up into the scion, which is huge for us. And I'm just providing one slide. Each of these slides are a publication or 2 publications, and you're welcome to look up my profile and find those publications if you have an interest. CRISPR, we have done a lot of work with CRISPR. This is an example of knocking out the phytoene desaturase gene, which is responsible for chlorophyll production. You knock out that gene, instead of getting green embryos, you end up getting milk white embryos, because there is no production of chlorophyll. It disrupts the pathway and you don't have production. So CRISPR is an extremely powerful tool. You can actually utilize CRISPR to knock out any gene that you want. And we have used it successfully to edit a number of genes. As I had mentioned earlier, our key focus is on systemic acquired resistance. And we understood early on that there were some negative regulators of the systemic acquired resistance pathway, specifically NPR3 and NPR4, that exists in the plant's genome. And these negative regulators do not allow the endogenous NPR1 to function as it should. So what can we do? Can we genome edit? Can we edit the NPR3? Yes, we can. We have done both NPR3 and we have genome edited NPR4 also. But this preliminary data shows that genome edited NPR3 plants are more resilient. Even though they have HLB, they get HLB, but the plant health is better. Some of the antioxidant genes, some of the phenolic content and DPPH were in inhibition, suggested that the disease severity was low. So even though you have disease in the plant, you're getting lower disease severity, which means they're willing to take tolerant tree. They don't want trees to be resistant. If a tree is tolerant and it produces flowers, fruits, okay, even after infection with HLB, it's okay. So this is a huge success for us, and hopefully we will work on this to see if it actually works out in the field. We're also doing another interesting, many other things. We are producing narrow angle citrus trees. So there's a gene called tiller angle 1. If you knock out tiller angle 1 gene, instead of trees being large and floppy, you can get trees with a very compact architecture. So basically you can actually do high density planting. You can also retransform those plants with other genes to produce what we call trap plants against the Asian citrus psyllid. So, as we look forward to the future, development of robust citrus populations by incorporating the genetics of wild citrus cultivars, it has been effective in the fight against HLB, and I would advise you to look in depth into what you can do. India, northeastern India has a lot of genetic diversity, and I think that genetic diversity should be utilized in breeding. We have also looked at genes, many genes from the systemic acquired resistance pathway, and some of them are working really well. And finally, CRISPR offers precise genome editing tools. I did not discuss any of the tools that we have developed because of time, but just the results. But it offers precise genome editing tools, and in the future can be utilized to develop non-GMO genome edited citrus trees. And there are some groups that have already done this in citrus to actually target genes that cause canker, for example, or susceptibility to canker. Thank you very much.
Globally, with all the diseases and pests and things that we face, we've got to do more on the genetic diversity within our cultivated crops, and I think you've really outlined a lot of the things that can be done, both conventional breeding and with bioengineering or genetic engineering. Lots of opportunity. And the one comment I just wanted to kind of mention again that you said was strong breeding populations for sustainable citrus production for the future. That's what we need to have to move things forward. So thank you very much for your presentation.
I agree. Thank you. Thank you.
I will request
All right, and for the delegates, we will be saving all the questions at the end of the plenary session just to save time so we can move forward in the agenda. And now I'd like to go ahead and call our next speaker to the podium, Dr. Kwangjon Song from Jeju National University in the Republic of Korea. And his presentation is a comprehensive strategy for fast breeding in citrus. Dr. Song.
Okay, thanks, Dr. Rogers, for introducing me. Also, that I would like to sincere thanks to the organizing committee Also, that special thanks to that Dr. Koshi. That it's really hard to organize this symposium. Anyway, that I feel that comfortable. Also, that very nice organization of this that first ASEAN CITUS Congress here. Also, that I'll start my talk that comprehensive strategy for fast bringing citrus. Before starting my talk, that I just start introduction of Jeju. Where is the Jeju Island? You can recognize that. What's that point? Okay. Yeah, you can recognize South Korea and a small island here, like this. Very that short, wide, and so yeah. So just that less than 1 hour, you can move from the north to south and west to east. Also, that you can look at this shape of the Jeju Island. Oh, you see that nice shape. You can recognize that one the mountain in center, located in the center of island. Is that almost that the height is Jeju Island, the 1,950 meters at sea levels. Just that seaside is the subtropical the climate condition, and center and the middle areas is that the temperate climate conditions. So that Jeju Island was created from several volcanic eruptions in that 2 million years ago. Yeah, that Jeju Island is mild that for the climate condition. You can recognize that less than the 30 degrees Celsius. Also that the loss of the rainfall to grow the citrus. You see that just rainfall from the June to September. Also that Jeju Island that we have that flowering season from that early May. We start harvesting citrus from the October. Usually that before end of that year, you can start the mandarin types in open field. But that on spring season, we harvested some mandarin in plastic house protect facility. Yeah, that you already know that Jeju Island is a small island, but it's really the special area because that you can recognize that we just grow that citrus just in that 20,000 hectares. Also that we produce more than 600,000 metric tons a year. Mostly the main citrus is that the Southern mandarin. You see that about that 80%. Oops, sorry. For that mandarin types. Also the other 20%. From that tangle, that hybrid between that mandarin and some that orange like this. You see that to that photos, we produce the high soluble sugar of citrus fruit using this that soil covering practice. Also that is that plastic house to produce that rain maturing mandarin types. Yeah, we have that long history for the citriculture in Korea for almost that 2,000 years. Also, the next move to that how is the citrus plant. That citrus plant is originate in the South area. You can recognize on these photos in the China, and all citrus relatives and citrus cultivars radiate to that outside of the China, the Europe, and the America, like that. Also, all these citrus plants belong to that genus and citrus. The share that the 9 haploid chromosome, almost same. Already mentioned that Manjul about that. Also, that the citrus species compose 3 basic species: pomelo, mandarin, and the citrus. Also, that genetic sequencing data represent almost 30,000 genes from that citrus specialty. Also that from the reference recent to the publication from here, yeah, the radiate from the wild type to that existing that cultivate citrus, the plant has modified their physiology so that the seed or the non-seed that from that monogenic monoembryon, that the polyembryon, and some that long juvenility like that. Also that almost that every year the global production of citrus has increased, including that China and India too. So that you can recognize all that cultivation area increase, also production has the same similar the situation compared to that cultivation areas. And yet we met the several the challenges to have that some the H value in some areas, including that Florida and that Brazil and in India too. But some countries don't have that HLBs. Also that we met some the challenge from that climate warming and climate changes, so that we need to improve that our operating systems. Usually, if we even though we improve that citrus fruit qualities, but consumers just want keep that similar price, so that global warming and the climate changes, so the increase of that costs, so that even though we improve that quality, but the growth doesn't satisfy that situation. So how to change this situation? I think that we developed the new cultivars with the distinctive the characteristics, so that if we can supply the different fruit shape or some taste, we can urge the consumers to pay a little more. So that this is my idea how to can we sustain our citrus industry in the future. So that I focus on how to develop the new cultivars in that limit the breeding period. So almost similar share similar breeding objectives, including India and America and Oriental countries, almost same. 4x, 2x, or that 2x is 4x, 2x and 2x, sorry, so that show the different that seed formation for that trichlor, that tetrafluoride. So you can improve that seed formation for that producing that trichloride. Also that we try to that produce that different cultivar characteristics, mostly in that reddish, pulp coloration like this. Yeah, we try to develop that new varieties like this. Also that we improve the selection using that DNA markers. We developed some SSL markers to detect the red field coloration, pulp coloration. Also that we try to develop that some difference, special that fruits with that yellow or that some that pink coloration in fields. Also that how to that develop or release that high tolerance to man pest and diseases. Already mentioned about this subject. Yeah, that Manjuls mentioned already, so that I want to skip this one for the saving that times. That after they release the new variety, the other one is that how to the plant new variety, replace that existing cultivars, so that we need to that advertise, to that inform that all the information to the growth, they can replace that the existing cultivars. So that also that new variety show that the different physiology, so that the growth doesn't know about that. So that we need to install that demonstration field to that growth that to approach that easily, and so that we can give that the lots of that information to cheer up that the replanting of the new variety. Also that when we compare the some that root stock trials, the same variety show that the different plant the physiological response, so that some difference that CD response, CD formation, and the fruit weight, and some soluble and acidity, so that we need try, testify some the different the environment condition. Also that we consider the shortage of that labor cost, labor, and the increase of the labor cost, so that the modern style in the near future will be changed like this, from that old style like this, but in the future like this. Some that other country they try to this style of that cultivation. So in Japan they tried, they want to growth change their planting systems, and then to reduce the cost, so that we need the approach, this style of that cultivation, to that improve that soluble solid fruit quality, also that reduce that labor cost. So also that most important is that how to protect the breed's right, so that the need to develop that some that DNA markers to distinguish that. So already in that commercialization, we did try this the marker system to distinguish that new cultivars. Yeah, that my talk is summarized like this, but I need just some that times to the advertise that the next fifth International Congress 2024 in Jeju Island in November 10th to 15th. That already, if you that for some that key word on the International Congress, you can catch some information. Also at the time that some special event, the International Expo will combine together so that I'm sure that if we visit that, my areas next year, you can catch that really that fruitful that information, the expertise and experience. Also that you enjoy that some fun. Is in that the nice, beautiful Jeju Island. Also that I welcome all of you to attend the next International Congress. I hope meet all of you in Jeju. Thank you very much.
Thank you, Dr. Song, for your excellent presentation, and we appreciate all the work you presented on speeding up the development of new varieties. As we face constant new challenges, both disease and pest, it's important to be able to take what's usually a multi-decade-long process to develop new varieties and get those out sooner, and also with characteristics that consumers want, because as you show, at the end of the day, it is, we want to be producing a crop that consumers want to buy. So thank you very much for your presentation.
Thank you.
Now I will request Dr. C.D. Mai, former chairman ASRB New Delhi, to present a memento to Dr. Song.
Thank you, sir, for doing the honor. Now we have very eminent speaker, next speaker, Dr. Michael E. Ruger. He's from the CITUS Research and Education Center, Florida. He would be speaking on the topic citrus Wanglong being research in Florida, past, present, and future prospect. Dr. Ruger, please.
Testing. All right, sounds good. And do I just hit? Okay. There we go. Okay, thank you very much for the opportunity to speak today. Appreciate the invitation, and it's good to be back in India. I was here about 15 years ago, and visited Nagpur then, and it's good to be back and see some familiar faces and get to see what's happening here in the industry. And a little bit before I start about my background, I am the director of the Citrus Research and Education Center at the University of Florida. And so I don't get to do the fun research that many of you get to do anymore. And so what I'm going to be talking about today is an overview of the work that many of the scientists are doing at the University of Florida related to Citrus Wanglong Bing. I'm going to talk a little bit about the past research when HLB first showed up in Florida, what we've been doing more recently to live with this disease, and then kind of wrap up with a few thoughts about the future, where we're headed with our research and what to expect going forward. And I want to start off with this slide that kind of puts it in perspective where we are in the state of, really in the state of Florida. The slide up here on the screen shows production of oranges in the United States for about the past 23 years, going back to 2000. If you look at the orange bars, those are millions of boxes of oranges produced in Florida. The blue bars are for California, and the red bars at the bottom are for Texas, which is primarily a grapefruit state, so that's a little deceptive there. But what you'll see is that prior to HLB showing up in Florida in 2005, we were producing more than 200 million boxes of oranges a year. And we were actually producing more oranges than there was demand for. We were really good at growing oranges. So then HLB shows up, and you'll see on the screen the arrow. That's when HLB was first detected. Now that big drop that year in production was not because of HLB. We had 3 hurricanes hit the state of Florida that year, And so that's where the production dropped. So it was not a result of HLB. But you can see after that point in time, we never really recovered. And over time, HLB started taking its toll. It was spreading through Florida, impacting our production. And so the presentation today, I'm going to talk about kind of two different time periods in terms of research, what we were doing, because the production at the time, at certain times of this scale here, really dictated what we were working on, and I'll explain what I mean by that here in a minute. But if you look at, say, the first 10 years of HLB in Florida, the research, that past research we did focus primarily on how can we slow disease spread. This was a new disease for Florida. It wasn't established very well, and so we were really trying to understand the biology of the disease, understand the psyllid, how to control the psyllid, so we could slow down HLB's progression. Then the next 10 years, which kind of encompasses where we are now going forward, what I'm terming current research, this really has been a transition from trying to understand the biology of the disease for us to taking what we've learned in the first 10 years to develop new grove management practices. In essence, right now we're just living with HLB in Florida and trying to adjust how we grow citrus to be successful in that endeavor. So if you look back to the first 10 years when we were trying to slow the spread, the early symptoms, this is what we saw throughout our groves in Florida. There would be small areas with individual shoots showing these yellow leaf branches, blotchy mottle, a little bit of fruit that was misshapen. During that time, you could go to trees, you could see it was having an effect on the fruit. The fruit quality was not as terrible as it is now, but we started to see that effect where a lot of the fruit was starting to become smaller. You still had some fruit on the trees that looked normal, but we started to see over time the quality. Many of the fruit were not, the standards we had had in the past. And so when we started out, this is nothing new to any of you all. Our approach was trying to scout and remove infected trees. We moved all of our nurseries under screen to keep them from being exposed to psyllids, and then of course psyllid control. Now, there was a lot of work done in these different areas on early detection and things like that. I don't have time to go into today, but because in the past I was an entomologist working on psyllid control, I will make a few comments about psyllid management and some of the things we did. And when I was working in that, the main thing we were looking at was what's the best approach for managing psyllid populations in Florida. And the psyllid populations get very high in Florida, and so we did some studies trying to develop management programs for growers. And one of the things that we did is we looked at the psyllid movement patterns. And this is some work done by Dr. Lucas Stalinsky. And if you look at this bullseye chart up there, in the very center, he had actually marked psyllids with proteins that aren't found in nature. And then we tracked those psyllids over the period of a week. We did mark and recapture studies. And what we found is that over a period of a week's time, those psyllids were moving more than a mile or more during that week period. And so the kind of the short story of this is that psyllids move very frequently between groves and long distance. And so it just showed that for a grower to go out and try to control psyllids in his own grove, he's not going to be very successful because the activities of all the groves surrounding his is going to affect the success. And so what we did is we developed an area-wide management program for psyllids. And we termed these the Citrus Health Management Area Program, or the CHEMA program. We divided the state, the commercial citrus growing region, up into about 50 different citrus health management areas. And the goal was that within these health management areas, the growers coordinated their pesticide application within a 2-week period. And the idea is that they could target those psyllids before they have a chance to really move around and get better control of the psyllid population. And this encompassed about 197,000 hectares of citrus. So it was a very big program. And we did a lot of research on the pesticides they should be using, the different application methods based on the pesticide being used, or vice versa. And because not every grower situation was the same.
Some had small acreage. They couldn't fly it with a plane. So maybe they're using these foggers in the back of a truck or something like that. So we developed a lot of options so the growers could pick and choose, and we could increase adoption and participation in the program. And so what we found is that within the first 6 months, if you look at the red line on the far right, those are the statewide psyllid populations in Florida in 2011. In the first 6 months that we had the CHIMA program going, just with 30 of these areas, we saw over nearly a 70% decrease in psyllid population just in the first 6 months. And so this area-wide coordinated application of pesticides worked very well. And it also played a really key role in helping us to mitigate or manage pesticide resistance. We started having a lot of issues with pesticide resistance in psyllid populations because we were spraying so frequently, and we were using a lot of soil-applied neonicotinoid insecticides on our trees. And so when we started having these growers coordinate their sprays, not only were they coordinating the timing, but they were also coordinating the mode of action over a large area. And so this was really area-wide rotation of products to help sustain and prolong the use of these important pesticides, and it worked very well. Now, what happens, it took us about 7 or 8 years before we could get growers to adopt that area-wide management program. And it was almost too little too late, because what you can see here is starting in 2012, that was probably the first year that we had a really significant fruit drop event because of HLB. These trees have been infected for 7 or 8 years, and over time the trees became weaker and weaker, and there comes a point where they just can't hold the fruit. And so 2012 was probably the first year that statewide in Florida we saw a very large drop of fruit because of HLB. And then if you go just a few more years forward, by 2015, it had become such a large problem that we actually fell below 100 million boxes of fruit production for the first time. So that was the beginning of the change in mentality of growers. We were no longer removing infected trees. Now we realized that we don't have enough fruit production to stay in business. And so we were doing everything we could to try to keep things moving forward. Now, about that time, probably one of the bigger breakthroughs we had that really helped us change our approach to managing the health of these groves was the understanding of what HLB was doing to the root system of trees. And our researchers discovered that, from the time that a psyllid feeds on a tree and infects that tree, you actually lose 30 to 40% of the root system before you see any above ground symptoms. And what happens is over time, these trees, the root systems become so weakened and they lose all their fibrous roots, they can't uptake water and nutrients properly, and they can't support that heavy crop load, and that's why you start to see the fruit dropping. And just to show you that tree, much larger image, you can see the root system. There's only structural roots left. All those fibrous, the roots that take up the water and nutrients are gone. So these trees are really starving to death. And it really meant that we're going to have to think about, if we're going to try to save these trees as long as possible and get some fruit production out of them, we need to change the way that we care for those trees. So that's really where the next big shift in how we're developing grove management practices came about, and where we get into some of the current research. And that's about developing new grove management practices to maintain the production of diseased trees, because all the trees in Florida now have HLB, and if we cut them all down, we'd have no production. So we're in the situation now that we're living with HLB until we can have some more sustainable solutions developed for the future. So one of the things we did starting out was focusing on root health, since that seems to be a key area where these HLB affected trees start to develop their problems. And in Florida, and I don't know how similar this would be here in India, but in Florida, a lot of our irrigation water is coming from way down below ground in the aquifer. We pump it up and we irrigate with it, but a lot of our water is very high in bicarbonates. And what that does is it raises the soil pH to above 7. It could be 7.5 or 8. And citrus roots don't like that high pH. They prefer a pH in the range of 5.8 to 6.5. And so one of the things we did to reduce that bicarbonate stress on the root system was start acidifying our irrigation water, or putting out sulfur or something to acidify the soil and lower that pH. And in groves where we started doing that, we were able to restore some of that root function and allow those roots to do a better job of taking up the nutrients that they needed. And so you can just see a shot here of a grove that was rehabilitated. The first step of that rehabilitation was managing the soil pH. Another thing that's really important, as you can guess, if your root system's not taking up nutrients properly, it's going to be the importance of proper fertilization. And we're going to hear more about this in several presentations. I know from folks here, our own Dr. Tripti Vashisht from University of Florida is going to talk more about the programs in Florida, what we're doing to ensure a proper balance of micro and macronutrients that really is helping us improve both canopy growth, fruit size and fruit quality, and also helps alleviate some of the plant stress or the stress on the plants that's caused by HLB. And so that's very important, and I think that's really the base of our programs going forward in HLB management, is starting off with good nutrition of the plants to keep them healthy or give them a fighting chance. And here's just another example of the effects that nutrition can have on fruit quality. This is a study that Dr. Vashisht and our flavor chemist, Dr. Yu Wong, did, looking at consumer preference for orange juice, where they had blind samples, either fruit or juice that came from plots where Dr. Vashisht had an optimized nutrition program with the right blend of micro and macronutrients versus the standard grower program that had been used out in the field. And you can see 58 out of 60 panelists chose the fruit that came out of the optimized nutrition plots. So consumers can tell a difference in the quality of juice when it's grown under the right conditions, despite the fact that it has HLB. So that is some hope there that, by adjusting these nutrition programs, we're not only improving tree health, but we can improve the quality of the product that we're providing to consumers. And also, another thing that's been done that's really showing a lot of promise for us in Florida is using plant growth regulators to mitigate some of the HLB-induced oxidative stresses on the plants. And Dr. Vashisht will talk a little bit more about this. It's some of her research that she's been doing over the past several years, looking at combinations or a schedule of gibberellic acid products, 2,4-D, and cytokinins applied at the proper time of year to help mitigate or reduce the stress on the plants. And I think we'll hear more about that this afternoon in one of the sessions. So I'm not going to go into any details there. But what we're seeing in Florida is that where growers are willing to take these new practices and really put in the effort, really do a good job with the nutrition program. It's not easy. They can get results like this. These are shots of groves that we're taking in Florida, not 20 years ago. It was last summer, and where a grower had worked on their soil pH, had the right nutrition program, was using plant growth regulators, and these trees look like HLB is not hurting them. I mean, you could find HLB symptoms in there, but they were having much better success. And we've had a number of growers who've been able to get the yields back up to close to 500 boxes an acre, which I think would be about 1,200 boxes per hectare. So that's really good production, considering that we've had HLB issues that have really decimated our crops. So it can be done. We have strategies right now. It's not easy, it's not cheap, but we have ways to keep our groves productive while we develop solutions for the future. It is tough getting growers to do the right thing and adopt these practices. And so I've got a few more slides of some things that are happening in Florida right now, because our growers always want something a little bit quicker and easier. Give us a silver bullet. And so we've had questions from folks, what are y'all doing in Florida with these trunk injection of antibiotics? And I'm not saying that I'm promoting this. I'm just providing you information because I've gotten a lot of questions about this. And this is nothing new. This is based on research that was done in the 1970s, where they injected antibiotics into trees to try to control HLB, and they showed they could actually improve fruit quality. You saw the percentage of fruit with HLB going down after they injected the trees with antibiotics. But there's always a downside to that, and one of them had to do with phytotoxicity. And they saw a lot of both foliar phytotoxicity symptoms, and internally in the tree, you saw a lot of discoloration and phytotox effects that ultimately affected xylem function. And so I think that's probably a lot of the reason, among others, why they stopped pursuing that. But there is work going on in Florida right now, maybe just repeating history. But this is work done by Dr. Uta Albrecht, And you can see the tree on the right, that's been injected with oxytetracycline. The tree on the left is the control. You can see a visible difference between the two. There is an improvement in tree health, fruit quantity, fruit quality, but when you look inside the trees, we're seeing some of the same things that was seen back in the 70s. There is a wounding and a phytotoxic effect, and so, you know, it's really, time will tell how well this is really going to work, because are we doing more harm than good with these injections? So I just wanted to present that because we get a lot of questions about, it's become a popular thing in Florida right now, and there is a lot of use of trunk injections, but I think there's still a lot more work to be done, and I would just caution people about moving forward with something like that. So for the future, we've heard a couple of talks about plant breeding already this morning, and I really think that is the future. For us in Florida, the future of our industry is dependent on having resistant trees that can withstand HOB, and whether it's conventional citrus breeding or biotech approaches, I think there's a lot of opportunities in both of those areas. We've already heard a little bit about that this morning. Dr. Dutt showed some slides of some varieties released. He didn't have these two on here, which I'm glad to say I can show something different than what Dr. Dutt showed. But one of the first releases from IPUS was called Sugar Bell Mandarin, and that's very HLB tolerant. And then also there was the OLL8 Sweet Orange, which has shown really good tolerance to HLB as well. In addition to the varieties that Dr. Dutt showed this morning, and a whole slew of other varieties that are coming out as well. So there's a lot of work that's being done in the pipeline in Florida on breeding of new varieties conventionally. Dr. Dutt mentioned we've got a lot of work going on transgenics. He's really leading that effort. There's a number, I'm not going to go into a lot of detail because he's already covered all of that this morning. I think much better job than I could do. But again, talking about transgenic scions, transgenic rootstocks, and I think the key thing that I want to pass along is that the Florida citrus industry is very supportive of us releasing a transgenic or a GMO citrus if we can get one that's going to be resistant to citrus greening disease. And so with that in mind, there's actually an effort underway right now. One of our researchers, Dr. Zonglin Mo, has developed 5 Hamlin sweet orange lines and 1 Duncan grapefruit line that express the Arabidopsis NPR1 protein. They do become infected with the HLB bacterium, but in the field they appear to have fewer symptoms, maybe at least we'll call it tolerance. And so there's an effort underway right now to get those deregulated through the EPA and the FDA in the United States. And if they're successful, that would be the first case of a GMO citrus variety being available, I think, anywhere. And so just want to let you know that that's something that's happening, and it'll probably take a couple of years to get through that process if they're successful in getting that released. So we'll see what happens there. And then lastly, we do have a lot of work going on with gene editing using CRISPR. And Dr. Nian Wong is one of our faculty members, and he was credited as being the first to use CRISPR to develop a non-transgenic new citrus variety. This was a canker-resistant Hamlin orange. Now, he's standing here in the picture. He's with some of the plants that are about to go to the field for the first field trial with that new variety. All the data we have right now on canker resistance comes from greenhouse or lab assays. So the caveat here is they've never been to the field, and so they're going to the field for the first time this year, and they'll be evaluated both for canker resistance and also HLB resistance, because some of the genes that are being targeted here do affect some of the oxidative stress pathways, and so there's always the potential that these trees could also show some increased tolerance to HLB as well. So those are going in field trials this year. We've already got them entered into our Budwood program with the state of Florida. So if they are successful, we'll be able to quickly move those out to growers through a commercial release. So a lot of effort and emphasis being put on biotech and breeding, because I really do think that is the solution for us going forward as an industry. And so that's just a really brief overview of what's happening in Florida. If you want more information about our programs, this website, citrusresearch.ipus.ufl.edu, pretty much all of our presentations, all of our materials that are printed. You can download copies online. I just encourage you to go online and have a look. And if you have any questions, feel free to reach out and let us know. So thank you all for your attention.
Thank you, Dr. Rogers, for an excellent presentation on the work done by the CITUS Center. In fact, you have shown us how the citrus HLB disease is spread from 2000 to 2005 when we detected it first in the Florida, then how it reduced the citrus production from 150 million boxes to 100 million boxes, then now it is even less than 50 million boxes. So the starting point from the removal of the tree to the silage control and to the protecting your nursery, even starting the clean plant program for particularly for the getting rid of the HLV disease. And a lot of good program is going on, starting from the conventional breeding to the transgenic approach and also using cisgenic approach. Not only that, using CRISPR-Cas and developing a number of lines that may be very useful in the future for the citrus industry. So thank you for the nice presentation. Now may I request Dr. Prabhat Kumar, Horticulture Commissioner, to do the honor to the speaker. Thank you. Now, chief guest is going to arrive here, so we will break here for the inaugural function. And after inaugural,
Esteemed Chief Guest Shri Nitin Gadkari sir, Honorable Union Minister for Road Transport and Highways, Government of India has arrived in the hall. Video sab ready hai na? I request our respected dignitaries to please occupy the dais as our chief guest Shri Nitin Gadkari sir is on stage. I request our guest of honor, DDG Horticulture ICR Dr. T.R. Sharma, our guest of honor, Professor C.D. Mai, ex-ASRB Chairman, our special guest, Professor Michael Rogers, Director CREC, Florida, USA, Professor Kwon Jong-song, Jeju National University, Republic of Korea, and Professor Dong-soon Kim, President, Korean Society of Citrus and Subtropical Climate Fruits, Jeju City, Republic of Korea, and along with our convener of Asian Citrus Congress 2023, Director ICR CCRI Dr. Dilip Ghosh to kindly grace the dais. Thank you, sir. I request the audience to welcome our dignitaries on stage with a big round of applause. Good morning, ladies and gentlemen, esteemed guests, delegates and participants. I, Dr. Sangeeta Bhattacharya, scientist of ICAR Central Citrus Research Institute, Nagpur, feel extremely honored to welcome you all to the Asian Citrus Congress 2023 in the beautiful city of Nagpur, popularly known as Santranagri, where brilliant minds from all around the world gather today to exchange ideas to shape the future of global citrus industry. We begin our inaugural session with the ICAR song, which heralds the scientific prowess of Indian Council of Agricultural Research.
जय जय कृषि परिषद भारत की सुखद प्रतीक हरित भारत की कृषि धन पशुधन मानव जीवन दुग्ध मत्स्य फल यंत्र सुवर्धन वैज्ञानिक विधि नव तकनीके पारिस्थितिकी का संरक्षण शस्य श्यामला छवि भारत की जय जय कृषि परिषद भारत की हिम प्रदेश से सागर तट तक मरुधरती से पूर्वोत्तर तक तक, हर पथ पर है मित्र कृषक की। शिक्षा शोध प्रसार सकल तक, आशा स्वावलंबित भारत की। जय जय कृषि परिषद भारत की, जय जय कृषि परिषद भारत की।
It's our honor to invite Honorable Minister Sir and all the dignitaries on the dais for lighting the auspicious lamp and marking the beginning of this 3-day journey of knowledge which we embark upon today.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः। शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः। शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते, दीपज्योतिर्नमोऽस्तु ते। शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः। दीपज्योतिर्परब्रह्म, दीपज्योतिर्जनार्दनः। दीपज्योतिर्परब्रह्म, दीपज्योतिर्जनार्दनः। दीपो हरतु मे पापं, सन्ध्यादीपनम्।
Music is a powerful tool that helps us align our mind, body, soul with our Supreme Creator. The Sarva Dharma Prarthana is a prayer of all religions which embodies the message of equality of all religions of the world. No matter what religion we follow, all of them lead us to the Almighty God, who is omnipotent, omnipresent, and pervades the entire universe. To make our journey of knowledge blissful, I now invite the group of students from Bharatiya Vidya Bhavan School, Nagpur, for performing the Sarva Dharma Prarthana invocation song.
I request the gathering to rise up for the Sarva Dharma prayer.
पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। हरि ओम् ईशावास्यमिदं सर्वं यत्किं च जगत्यां जगत्तेन यत्तेन पूजिताः माद्रिदः तस्य सिद्धनम्। औज़ु बिल्लाहि मिनश्शैत्वानिर्रजीम। अल-फतिहा। बिस्मिल्लाहिर्रहमानिर्रहीम। अल्हम्दुलिल्लाहि रब्बिल आलमीन। अर्रहमानिर्रहीम। मालिकी यौमिद्दीन। इय्याक नअबुदु व इय्याक नस्तईन। इहदिनस सिरातल मुस्तकीम सिरातल लज़ीना अनअमत अलैहिम गैरिल मग़दूबि अलैहिम वलद्दॉलीन। Amen. Let kindly light amid and circling gloom. Let dawn be on. The night is dark and I am far from home. Let dawn be on. Keep the अशारतुष अशाचितशा वंगये उष्मश्चामनंगहो शौतन्नामं वंगये उष्मश्चाई क्षते मचा औराई आई ग्लेदुपयो ददद्वास्तारिम अशेमहो वरिष्ठे अष्टिरुष्टा अहमाई यत अशाई वरिष्ठाई अशीम बुद्धं शरणं गच्छामि धम्मं शरणं गच्छामि संघं शरणं गच्छामि। एक ओंकार सतनाम कर्ता पुरुष निर्भय निर्भय अकाल मूर्त अजनी सैभम गुरु प्रसाद जप आदि सच जुगादि सच है भी सच नाना को से भी सच वाहे गुरु जी का खालसा वाहे गुरु जी की फतेह। ओम नमो अरियंताणम ओम नमो श्री सिद्धानम ओम नमो आयरियाणम ओम नमो वज्रायाणम ओम नमो लय सब साहूणम ऐसो पंच नम कर सब पाव पर्ण सण मंगल ज सब सी परमं हवै मंगलम मंगलम मंगलम। ओम सहनावतु सहनो भुनक्तु सह वीर्यं करवावहै तेजस्विना वदितमस्तु मा विद्विषावहै। ओम शांति शांति शांति।
Thank you, students. I now request Dr. Dilip Ghosh, convener of ACC 2023, President of Indian Society of Citriculture and Director ICAR CCRI, to felicitate our chief guest, Honorable Union Minister for Road Transport and Highways, Shri Nitin Gadkari ji, by offering shawl, shriphal, bouquet and a memento. I request Dr. Dilip Ghosh to felicitate our guest of honor, DDG Horticulture, ICAR, Dr. T.R. Sharma, with a shawl, shriphal and bouquet. I request Dr. Ghosh to felicitate guest of honor, Professor C.D. Mai, ex-ASRB chairman, with a shawl, shriphal and bouquet. I request Dr. Ghosh to felicitate our special guest, Professor Michael Rogers, Director, CREC, University of Florida, USA, with a shawl, shriphal and bouquet. I request Dr. Ghosh to felicitate our special guest, Professor Kwon Jong Song, Jeju National University, Republic of Korea, with a shawl, shriphal and bouquet. I I request Dr. Ghosh to felicitate our special guest, Professor Dong Soon Kim, President, Korean Society of Citrus and Subtropical Climate Fruits, Jeju City, Republic of Korea, with a shawl, shriffle, and bouquet. I would like to request my scientist colleague, Dr. Naresh Meshram, to felicitate Dr. Dilip Ghosh with a bouquet. Now I request Dr. Dilip Ghosh, convener of ACC 2023, President of Indian Society of Citriculture, to present his welcome address.
Good morning, dignitaries on the dais, most respected Karma Yogi, Vikas Purush, Sri Nitin Gadkari ji, Honorable Minister for Road Transport and Highways, Government of India, and the chief guest of today's program, Dr. T.R. Sharma, Deputy Director General, Horticulture Science, ICAR New Delhi, Professor C.D. Mai, ex-chairman ASRB New Delhi, Professor Kaon Song, Jeju National University, Republic of Korea, and the former president of Korean Society for Citrus and Subtropical Climate Fruits, Dr. Michael Rogers, Director, Citrus Research and Education Center, Florida, Dr. Kim Dong-sung, present president of the Korean Society for Citrus and Subtropical Climate Fruits, who is also the co-host of today's international event. Other distinguished guests present in this hall, Director, Vice Chancellors, Horticulture Commissioner, ADGs, Project Coordinator, Director of Research, Heads of different departments, Director of Horticulture of different state government, and large number of delegates coming from India and 15 different countries like US, Brazil, France, Spain, Iran, Turkey, Tunisia, Kenya, Algeria, Korea, Nepal, Malaysia, Philippines, Vietnam, Bhutan, ladies and gentlemen. I consider it as my proud privilege and great honor to stand in front of you to welcome Honorable Sri Nitin Gadkari ji, a popular name across the country and outside because of his significant contribution in the field of road transport and highways, who is the symbol of development, dedication, and humanity. Truly, Sri Gadkari ji is a national icon, a multifaceted personality, and a role model to all of us. We feel proud that Sri Gadkari ji is the son of this soil, from this orange city, having roots in agriculture, and also has tremendous passion for developing agri-horticulture sector of the country. We are fortunate that we have a true guardian over our head to guide us, to bless us, and these feelings give us a sense of huge comfort and confidence. Let me confess very honestly, last year, while I was attending one official meeting where emerging challenges of the citrus growers of Vidarbha region of Maharashtra were being discussed, Honorable Gadkari ji asked me whether we can organize one brainstorming event where citrus experts from different leading countries can join, discuss, and come up with some implementable solutions that will benefit the citrus growers. I immediately accepted his advice and decided to hold this international event. And as a result, today we are here in this hall. Sir, we are absolutely delighted. Sir, we are absolutely delighted to welcome you in this mega event, Asian Citrus Congress 2023, which is your brainchild. First of its kind in the world, being attended by nearly 300 delegates from different countries of the world and 20 different states of India, where we'll discuss, deliberate, and draw the future roadmap for the betterment of the citrus industry. On behalf of ICAR, Central Citrus Research Institute, Indian Society of Citriculture, and as the convener of Asian Citrus Congress 2023. I also extend warm welcome to other dignitaries on the dais, delegates and participating scientists, technical experts, policymakers, extension personnel, and my student friends, both from public and private institutions, to this event. Once we look at the present horticulture scenario in the world, citrus is considered as one of the most important food crop grown in more than 150 countries, of which 53 countries of different continents grow citrus commercially with a total production of about 162 million tons that provides significant source of income and employment for millions of farmers, processors, traders, and others associated with the value chain. India stands third after China and Brazil in the production. Collectively, India, along with all other major Asian citrus producing countries, contribute about 52% of the total citrus production of the world, but faces more or less similar challenges in this continent, whether it is unavailability of quality planting material, lack of varietal diversity that limits the choice of consumers for fresh food, less productivity as compared to Western countries, occurrence of new and emerging diseases, particularly of citrus greening, that has caused havoc damage to the citrus industry, phytophthora-induced diseases, citrus canker, citrus scilla, citrus fruit fly menace still poses serious threat. Climate change and its adverse effect are clearly visible in different parts of the world. Lack of export quality fruits, processed products are some other challenges Asian citrus countries facing. To address all these challenges and to harvest the full potential of the industry, it is essential to connect talents from different fields and specialization towards advancing this sector. Asian Citrus Congress 2023 provides a common platform for all the stakeholders and bring together global experts to share their knowledge, experience, expertise, innovations, and skills to address all these challenges. During last few decades, there have been a tremendous developments towards science and technology-based solutions for various challenges of the global citrus industry. The use of cutting-edge technologies like genome editing for developing improved citrus varieties, identification of antimicrobial peptides for disease and insect control, application of nanotechnology, artificial intelligence, IoT, drones, and robotics are few examples that can revolutionize the future citriculture. Mechanization and automation are already in use for irrigation, pruning, spraying, and harvesting to enhance efficiency and to reduce the labor cost. Soil health, water resource management, and climate change adaptation strategies are crucial for long-term sustainability of citrus industry. Promoting citrus for its health benefit and organic cultivation can tap into the growing demand for healthy and safe fruit. Post-harvest management practices, including handling, packaging, storage, it needs further development to reduce losses and maintain fruit quality. Citrus processing waste can be valorized and used as a raw material for manufacturing biofuels, enzymes, vitamins, and many other items. ICRCCRI Nagpur, along with its All India Coordinated Research Centers, has done a remarkable job for the betterment of the Indian citrus industry. And we are ready to collaborate. We are ready to join hand with other industries of the world. Along with these scientific issues, I also invite your thoughts in few related issues. Can we plan or can we think of establishing Asian Citrus Council with the participation of major Asian citrus producing countries that will strengthen research collaborations to address common challenges of diseases insect pests, exchange of citrus germplasms, exchange program for scientists, students and farmers, formulating new trade policies and agreement to reduce trade barriers, establishing mechanism for the transfer of agricultural technologies and best practices, developing and adopting common standards for citrus production, quality control, and certification across the Asian countries that will ensure product quality, facilitate trade, and thus will make Asian citrus products more competitive in the global market. I am extremely happy to see many eminent citrus scientists present in this hall, and it is not possible to mention all names. But I must mention few names, like Professor S.M. Shantra from University of Central Florida, Professor Bhimu Patil from Texas A&M University, Dr. Chandrika Ramadugu from University of California, Dr. Manjul Dutt, Dr. Tripti Basis, Dr. Lodias Cordero from Citrus Research and Education Center, Florida, Dr. Franklin from Brazil, Dr. Ian from France, Dr. Hua from Vietnam, Dr. Ritu Raj from Spain, Dr. Albin He from Malaysia, Dr. Mehdi and Mousha from Iran, Dr. Mejin Mallika from Algeria, Dr. Henry from Kenya, Dr. Umesh Achera from Nepal, Fengshu Wangdi from Bhutan, Dr. Song Kim from Korea, and many other friends who have traveled several thousand miles from their respective countries to attend this event. I am also very happy to see Professor Roshini Kumar Sharma and Professor Harsh Chauhan from IIT Roorkee, Dr. Prabhat Kumar, Dr. V.B. Patel, Dr. Krishna Reddy, Dr. Baranwal, Dr. Prakash Patil, Dr. Marathe, Dr. Morkute, Dr. Sunil Parekh, Dr. S.S. Pandey, Dr. Y.G. Prasad, and Dr. Patil, and others who could make it. Lastly, I must express my sincere thanks and gratitude to all the esteemed sponsors for their invaluable support and contributions. That has played a significant role in converting our dream to host this international event into a reality. With a small but effective team, we have tried our best to organize this event as a very special, so that your 3-day stay in Nagpur is comfortable in all respect, and you get proper time and medium for your best scientific presentations in 5 different technical sessions. If you are happy, the entire credit goes to my team who are working for last 6 months. If there is any inconvenience and any mistake, as the convener, I take the responsibility and beg apology for that. Once again, I wholeheartedly welcome all the distinguished guests in this historic moment. I am very confident with your active involvement, intellectual contributions, and knowledge sharing, we'll certainly come up with some valuable recommendations and implementable action plan at the end that will benefit the citrus industry, contribute in food and nutrition security for the mankind, and certainly work towards the growth and prosperity of our one earth, one family, and one future. Thank you very much.
Thank you, sir, for your heartwarming message. Now I would like to call our guest of honor, Professor C.D. Mai, ex-ASRB chairman, for his address.
Honorable Chief Guest of this function, and who is originally a Nagpurian, Mr. Nitin Gadkari ji, my old friend, Deputy Director General Crops and Horticulture, Dr. Sharma. Today we have a guest amongst us from outside the country, Kwan Song Song, Michael, and also soon, Dr. Ghosh. I find lots of directors of our ICR institutes vice chancellors of the university, and many friends in the audience. I welcome also those delegates who are coming, as Dr. Ghosh has said, from abroad to join us for this Asian Citrus Congress 23. Friends, as Dr. Ghosh has already added his welcome, being a Nagpurian, I would also like to add my welcome to all of you to this Orange City. Basically, the city is known as Orange City. Probably there are few cities which are named after fruits, but this is one of them. And there is only one Orange City in the entire world, and that is Nagpur. I am happy that you are all here. Actually, the name captures the spirit of the city's character and also encapsulates both its cultural significance and citrus-based prosperity. In fact, you probably may be not knowing that this particular area was ruled by a Raja, Bhosles, in 18th century. And this culture of citrus was originally brought in 18th century by Bhoslas in this particular area, which has flourished because of the climate and soil. I think this very specific, as you say, normally we call it as Nagpuri Santra, is very special in terms of its flavor and aroma, which is blended into a sweet and tart, mainly because of the tropical wet climate and the typical soil that is vertisols. Over the years, Nagpur oranges are losing the flavor of farmers. I think you have already seen Dr. Michael's and the earlier presentation, how there has been a lot of decline in Florida, which is also considered one of the hub of the citrus. I think many things which are also happening in this region, where we call it as orange region, there is a lot of decline in now the oranges here. And that is mainly because of, I think, mainly because of climate change, mainly because of pest, and a large number of diseases which are actually occurring it. Now this fluctuation of weather to a great extent has been responsible for a lot of ups and downs in the citrus industry. Friends, the major problem to me, it appears, is, I think, also was very well recognized and said by Michael very recently in his presentation, is the depletion of soil fertility. We have not very critically looked into what are the needs of deficiencies like what micronutrients, macronutrients, supplementary nutrients, etc. Now they are all threatening basically a lot of decline of the citrus industry, which you have to look into very critically. NRCC, which has done wonderful, CCRI, which has done very wonderful job in terms of really producing the virus-free seedlings in this region. I compliment them, and they have actually introduced this particular area, and now also certifying some of those agents, private nurseries, is a very important step for really providing virus-free material to the farming community of this area. How this basically, the plant material which is of citrus important is already well known all over the world. Certainly there are common problems which possibly now in this Asian conference can be discussed. I think this is the purpose of the Congress, where similar problems, how the approach has been done, like what they have done in Florida, can we do some of those things like biotechnology, CRISPR work on some of those problems which were existing here, and it's not that difficult. So we have to introduce that, and in this conference I am sure that there will be a lot of dialogues, between the scientists, and they will come out with some kind of a defined recommendations. And maybe, as he said, we can formulate some kind of a inter-institutional projects where we can contribute to each other. I am sure that such conferences will ultimately lead to some kind of a new things for the farming community. Let me tell you that citrus industry as a whole in this region is actually, I will not say, but it is declining. And there are, I think, as I said, there are lots of reasons for that. But if we have to maintain, because Nagpuri Santra or Nagpur region is very famous, and the economy of citrus farmers is totally dependent on citrus culture. So I would say that whatever now we do research, can we translate some of them into farmers' field would be a very big sort of a boon for the entire area. And I am sure that the conference being held in Nagpur will definitely benefit the farmers. I am looking forward for the deliberations of this conference and wish you all a wonderful time in Nagpur in this particular period. Thank you very much.
Thank you, sir, for your enlightening message. Now I would like to invite our guest of honor, Dr. T.R. Sharma, sir, for his address.
Very good morning to all. Honorable Chief Guest of the day, Shri Nitin Gadkari ji, Honorable Minister of Road Transport and Highways, Government of India. Guest of honor, Dr. C.D. Mai, former Chairman ASRB New Delhi, Dr. Dilip Ghosh, Convener ACC 2023 and Director of ICAR CSS RI. Our guest from abroad, Dr. Kon Jion Song, Dr. Michael Roser, Dr. Dong Son Kim, my colleague from the Council, Dr. B.B. Patel, ADG Horticulture, distinguished Vice Chancellors of different universities, Directors of ICR institutes, delegates, participants from different countries, ladies and gentlemen. I would like to first of all welcome Honorable Union Minister Shri Nitin Gadkari ji on behalf of Indian Council of Agriculture Research, New Delhi, as well as on my personal behalf. Well, delegates, it gives me immense pleasure to extend my warmest greetings to all on the occasion of the Asian Citrus Congress 2023, organized under the thought-provoking theme, Advancing Citriculture for Agroeconomic Prosperity. As we gather here from across the globe, we embark on a journey of discovery, collaboration, and innovation in the realm of citriculture. Citrus is one of the world's most important fruits, grown in more than 150 countries and are regarded native to subtropical and tropical parts of Asia, Iceland, Southeast Asia, near Oceania, and Northeast Australia. The history of citrus in Asia is one of the top 3 fruits in the continent is highly fascinating and offers many opportunities for learning for citrus scholars. The genus Citrus is native to Southeast Asia, Melanesia, and Australia. Various citrus species have been used and domesticated by indigenous cultures in these areas since ancient times. India, known for genetic diversity of citrus, covering 27 native species, is third major producer of citrus in the world, contributing 10.76% area under citrus and 8.84% citrus production in the world. A total 11 citrus varieties have been recognized under GI, like Nagpur Mandarin, Kurg Mandarin, Khasi Mandarin, and Kachi Lemon, to name a few. The major citrus growing belt in India, like Maharashtra, Madhya Pradesh, Telangana, Andhra Pradesh, and Tamil Nadu, have distinct tropical climate where temperature goes beyond 40 degrees centigrade. Mandarin orange is most common among citrus fruits grown in India. It occupies more than 40% of total area under citrus cultivation in India. The most important commercial citrus species in India are the mandarin, sweet orange, and acid limes. In India, citrus have unique flowering pattern, especially in central India, have 3 blooms. For example, Ambia Bahar, Mariz Bahar, and Hasta Bahar. So, the remarkable diversity of citrus species and their versatile application have not only enriched our country culinary experiences, but also contributed significantly to the agriculture and economic landscapes of many nations. Citrus has significant nutritional values in human food. It is rich source of vitamin C, organic acids, amino acids, mineral like calcium, magnesium, and various other phytochemicals compounds that are responsible for good health. This Congress provides a unique platform for researchers, practitioners, stakeholders in the field of citriculture to exchange insights, share experiences, and collectively explore pathways that lead to agroeconomic prosperity. We have to understand the difficulties caused by changing weather patterns, emerging pests and diseases, and altering market dynamics to develop comprehensive plans of actions that improve the livelihood of farming communities and that depend on citrus production system. I extend my heartiest appreciations and congratulations to the Indian Society of Citriculture, organizers, sponsors, presenters, and all those who have contributed to making the Asian Citrus Congress 2023 a reality. I hope that this event serve as a valuable opportunities for experts and stakeholders in the citrus industry to network, collaborate, and stay updated on the latest developments in the field. And I would like to wish you all a fruitful and insight discussions during the Congress. Jai Hind.
Thank you, sir, for your brilliant message. Moving forward to the publication release session, we have 3 publications set for release today. So I request Honorable Minister, sir, and other dignitaries on the dais to kindly release our first publication, which is the Souvenir of Asian Citrus Congress 2023. The second publication for release is a book titled Citrus Diversity in India. I request our dignitaries to kindly release the book. The book is the first volume of Indian Citrus series authored by Dr. A. Murkute, Dr. A. Thirugnanaval, Dr. J. P. Tejkumar, Dr. R. K. Sonkar, Dr. S. S. Roy, and Dr. Dilip Ghosh. The last publication for release is the second issue of Indian Citriculture e-magazine, which is being published by Indian Society of Citriculture at 6 monthly interval. Though it's an e-magazine, but we have taken efforts to provide hard copies of this magazine to all our delegates of this conference along with the registration kit. Thank you. Moving forward to the award distribution session, I invite my scientist colleague, Dr. Venkatraman Bansode, for the session.
Thanks, Dr. Sangeeta. We will be awarding 6 eminent scientists who had applied for ISC Fellow among the life members and selected by a duly constituted committee of experts. I request all awardees, after receiving your award, please wait beside the stage for a group photo. I request Honorable Minister Sir to award the selected ISC Fellows. I would like to call Dr. Surendra Kumar Malik. Dr. Surendra Kumar Malik, presently working as Principal Scientist in ICR National Bureau of Plant Genetic Resources, New Delhi. He has significantly contributed in management of citrus genetic resources and its molecular characterization. Next one, Dr. Dinesh Paithankar. Dr. Dinesh Paithankar, Associate Professor in Horticulture at Punjab Rao Deshmukh Krishi Vidyapit, Akola, Maharashtra, has done significant work in fruit breeding and contributed in the development of citrus varieties. Third one, Dr. Sandeep Singh, a principal entomologist in Punjab Agriculture University, Ludhiana, has done commendable work in eco-friendly management and emerging insect pest management of citrus. Next one, Dr. R. A. Marathe, presently working as
Therefore, I congratulate all of you for organizing this unique event. Friends, CITUS is grown in more than 150 countries. Out of these, 53 countries grow citrus commercially with a total production of more than 160 million tons. On production basis, as you all know, China tops the list with more than 46 million tons, followed by Brazil with around 90 million tons. India occupies the third position with a production of 14 million tons. The world citrus is dominated by sweet orange, occupying around 48%, followed by mandarins, occupying 25%, limes and lemons 13%, and rest of other citrus fruits occupying around 14%. In India, the area under citrus is about 1 million hectares, with a production of, as I mentioned, 14 million tons. That means average productivity of citrus in India is around 14 tons per hectare. Indian citrus industry is worth of rupees more than 31,000 crores annually on the basis of raw fruit alone. And only 4 to 5% fruit is processed, while rest is consumed fresh. India exports about 90,000 tons of citrus worth of rupees 225 crores. Friends, Indian citrus industry has certain unique features. Mandarins and sweet oranges are grown under tropical climatic conditions. And the famous Nagpur orange, mandarin, where all of you are having this particular congress, is grown in humid tropical Vidarbha region of Maharashtra, where the summer temperature reaches as high as 45 to 46 degrees Celsius. Both Maharashtra with 0.3 million hectare area under citrus in central India, and Andhra Pradesh with 0.12 million hectare in South India enjoy a distinct tropical climate where there is no well-defined winter season with low temperature. As citrus is being widely grown across the country, its cultivation also faces variety of problems. Threats of insect pests and diseases, nutrient deficiencies, scarcity of water in certain areas, lack of post-harvest handling along with processing infrastructure, and several other problems have put a lot of limitations for increasing the productivity and production of citrus in this country. Fortunately, our institute, Central Citrus Research Institute, Nagpur, has developed several varieties for cultivation, and those varieties are getting very popular with the farming community in Maharashtra and elsewhere. The institute has also developed several management technologies, including microbudding protocol, which was standardized, in which the microbudded plants are ready in 12 months as against 18 months in conventionally budded plants, thus saving on cost as well as time. Microbial consortium for better soil health was also standardized. Leaf nutrient and soil suitability tailored were developed, and integrated nutrient management schedule have been standardized to save 25% or more of chemical fertilizers. I'm happy to know that the institute produced and distributed more than 50 lakhs disease-free mother plants of different citrus cultivars with a revenue generation of rupees 15 crores a year. Once again, I welcome you all for this Asian Citrus Congress 2023, which has been organized by Asia Central Citrus Research Institute, Nagpur, along with Indian Society of Citriculture. And as you know, this is one of the first very important scientific event which is being attended by around 300 delegates from India and 15 other countries. So welcome each and every one of you, and I wish you all a very thought-provoking, meaningful, and very successful Congress. I will be really waiting for the recommendations which will be emerging from the deliberations in this Congress for their further consideration as well as possible implementation. And I wish this Congress a grand success, and I congratulate the organizers, the institute, and the society for conceptualizing, for planning, and finally organizing this particular event. Congratulations to each and every one of you, and welcome again each and every one, particularly those who are joining from the other countries. Wish you all success. Jai Hind.
I would like to thank DG sir for his thought-provoking video message. Now it's time to honor 6 eminent personalities of global reputation with the prestigious Honorary ISC Fellow Award, for which I invite Dr. Bansode again to the stage.
Thanks, Dr. Sangeeta. I request the awardees, after receiving your award, please wait beside the stage for a group photo. I request Honorable Minister Sir, to award our honorary ISC fellows. Now I would like to request call upon Dr. Kwon Jong Song. Dr. Kwon Jong Song, presently working as Distinguished Professor at Jeju National University, Republic of Korea. He has significantly contributed in citrus genetics, breeding, and molecular physiology. Next one, Dr. Swadesh Mukul Sandra. Dr. Swadesh Mukul Sandra, he is Distinguished Professor in Chemistry at University of Central Florida. He has outstanding contribution in crop protection. He has developed several nanotechnology-enabled tools which are helpful in controlling the citrus canker and HLB. Dr. Michael Roger, presently working as Director, Citrus Research Education Center, University of Florida, USA. He is an eminent professor of entomology and has been made significant contribution in the arena of insect and pest management of citrus crops. Next one, Dr. Ashwini Kumar Sharma. Presently working as professor and head in Department of Bioscience and Bioengineering, IIT Roorkee. Next one, Dr. Bhimanegoda Sanjanagoda Patil. He is a renowned professor at Texas A&M University, USA. Next one, our next awardee is absent, so next awardee is Dr. Siddharamaya Gowda is absent, so I request Dr. Michael Roger to receive award on his behalf. Dr. Michael Roger, on behalf of Dr. Siddharamaya Gowda, is receiving the award.
Congratulations to all the esteemed fellows. Now it's time to hear our honorable chief guest, Shri Nitin Gadkari Sir, Union Minister for Road Transport and Highways. I request Sir to kindly address all the participants who have gathered here today from across the world. Before that, we'll have a group photo. I request our Honorable Chief Guest Sir to kindly address the audience.
Dr. T.R. Sharma, Deputy Director General, Dr. Dilip Ghosh, Convener, Asian CITUS Congress, and Director ICAR, CCR, President ISC, Dr. Kong Song from Korea, Dr. Michael Rower from USA, Dr. Kim Dong-sun from Korea, all respectable dignitaries and dear friends. First of all, being a member of Parliament from Nagpur, I welcome all of you in this orange city of Maharashtra. This city is known as Orange City. The 0 mile of the country is in our city, and the city also known as a tiger capital. From 2.5 hour distance from Nagpur, we have 350 tigers. So today it is a great pleasure and pride for me. The expert people who are coming from abroad here in Nagpur for this conference and the guests from all over India, I am welcoming all of you. Orange is very important crop for particularly in our Vidarbha area, which is a part of Maharashtra. It is very important for the farmer. Presently from last many days, our institute and research scholars are working and making different type of research related with the crops. Presently, I am also a farmer and orange grower, mosafi grower and lemon grower. So today I am also a person who actually grassroots level related with the crops. The most important thing, the problem which we are facing is related with the productivity and the quality. We need disease-free plant having good quality, good taste and productivity. Dr. Mr. T.R. Sharma is here and I will request him. Today the capacity of giving orange plants from the institute is only 3 lakhs. I constantly pursue that if you have not have that capacity, you should have a joint venture nurseries under your guidance and direction. They can make the quality production of orange plants. So after that 10 to 12 people they have given the permission. And now the capacity is going to 30 lakhs. But the requirement, the market demand is for 1 crore 70 lakhs. First of all, my request to particularly Deputy Director General T.R. Sharma that allow them and give them permission and formulate the policy by which they can select the nursery and increase the productivity as far as the plants are concerned, and where it can be easy for them to availability of plants all over India to the farmers. Now the second important thing is we need disease-free plant. Now I understand, I know that region to region, district to district, climate is changing. So the climate in Korea, climate in USA, climate in India, and climate in Israel is different. And that is the reason that we need to find out exactly the appropriate nursery which is going to give us the plant which are suitable for the climate. Everywhere there are 4 things are very important. One is proven technology, second is availability of raw material, third is economic viability, and fourth is marketability of the finished product. Now the marketability and market is a big problem, but that is our responsibility. We will find out the way of solving. But regarding nursery, it is a problem related with the our particularly ICAR, and it is the time for the country, that dream of our Prime Minister, to make Indian economy, which is number 5, the dream of the Prime Minister to make third largest economy in the world, to make the economy of $5 trillion. And the agriculture growth rate is only 12%. The manufacturing sector contributed GDP growth is 20 to 24%, and the service sector 50 to 54%. When I was minister in Maharashtra, I got offered to construct Mumbai-Pune Express Highway, 55 flyovers in Mumbai and Valli-Mala ceiling project in Mumbai. Once in a conference, journalist asked me the question. Then I just naturally elaborated that if there is a will, there is a way. And if there is no will, there is only survey, discussion, seminar, committee, subcommittee and research group. So probably, I don't want to criticize anybody. I will respect your research. But ultimately your research is not going to help the grassroots farmer. Then what is the use of it? So that is exactly, you need to find out the solution and to create cooperation, coordination and communication between the stakeholders. And here the government agency's performance is not up to the mark. Where we are expecting that you should have an association with the farmers, you should have a quality plans with concerning disease-free plans, giving good quality, good productivity. That is the responsibility up to your level. But still from last 50 years, we have this Orange Research Institute. Now it is just coming, I know, but it probably from 30 to 40 years. But still in the Nagpur area, it is not up to the mark as a farmer we are expecting from them. And it is not their problem, it is the problem with you. The people who are sitting in Delhi, I am the minister. And we need to have an appropriate policy. The futuristic technology, futuristic vision, and futuristic planning for next 25 years is very important. And that is the reason that it is your outlook. That whether it is the Korean plant is good, or California plant is good, or Israeli plant is good, or Indian plant is good, that is not our concern. It is the concern with the scientists and the officers. You have to contribute and guide us. That as far as we are making the joint venture with this, and because of that, this can be an absolute good plan for your area. And the basis of that from your nursery, if we get the plan, then we can do it. Now for getting plan from nursery, the people need my recommendation to them. And I am giving recommendations, still they are not in position to give the plan to the farmer. Then what is the use of it? I am very sorry for that. If you have a capability and capacity, you could fulfill the demand. If you don't have the capacity, make the joint venture with the good nurseries and make the availability of the plants. But ultimately you have to resolve the problem. You should be loka bhimu. And that is to be the expectation from the farmers. As a minister, I am really happy that Mr. Ghosh is doing seriously, trying his level best. But up to I know that how the government works. On the highest level, when the government formulates the policy, then only it can happen. And that is the reason that my request is to make the availability of at least 2 crore plants in the country disease-free, good productivity, good taste, and understanding the climate situation in area to area, district to district. We need your guidance, your cooperation by which we can make the success story. The other important thing is the market. We have a good market of Bangladesh. But Bangladesh increased the duty by 180% on our oranges. Our logistic cost is very high. We have to take the oranges up to Bangladesh by transport. The cost is very high. And today, I am trying from last many years, but now we have succeeded that we are making dry port, satellite port in Nagpur, near Sindhi. by which here we can take oranges up to the Haldia in the Calcutta, and after that from river we can take oranges up to Bangladesh. So we will reduce the cost by 1,50,000 rupees per container. To reduce the logistic cost is our responsibility. To start the processing industries is our industry, our responsibility. The Ramdev Baba has taken the initiative for making a big factory in Nagpur, in Bihar. Now I am pursuing with him, and probably within 1-2 months he is going to complete that plant. Then there will be a market for that. The mother dairy is going to start the expansion of their manufacturing in Nagpur of 450 crores. In our agrovision, we have a program, and where I am insisting them for orange burfi. The burfi is very beautiful, but presently they are manufacturing this orange burfi in Delhi. So now in Nagpur also they are planning for that, and people who are coming to Nagpur, their interest is to purchase this burfi. But the burfi available in the market is not orange burfi exactly. They are using other things for that. So we have completed the research. The mother dairy has taken the responsibility, and as early as possible we are going to launch this orange burfi in the country. I feel that today we need to increase agriculture growth rate, and for that reason, without that we cannot make Atmanirbhar Bharat. And for that reason now we have started using technology. By using nano urea, and now we can save the cost of the fertilizer. In place of 2 bags of urea, we can use 1 nano urea bottle by using it, by taking the advantage of the technology by using drones. In my area, we have taken drone spraying on 3,000 acres of sugar cane. The productivity is good. When we are using urea or mixed fertilizer by traditional system, the 75% is lost and 25% is going to the plant. But by using drone, it can give us 25% only wastage and 75% going to the plant. So we directly save the cost of the fertilizer per acre. We need to reduce the cost, expenditure cost, increase the productivity and quality by giving more profitability to the farmers. The economic viability is very important. Today, some of the time it is because of the climate heavy rains we face the cost. Now this year in my own market we are facing problem because of heavy rains, and that is the reason that total our orange crop is collapsed. But we cannot blame it for anybody. But by using good technology, how we can increase the productivity, how we can make disease-free plants, how we can transfer the technology in joint ventures with the private nurseries, and how we have a good nursery in the different part of the country where they can fulfill the expectation of the farmers. I am really happy this is a very important conference. I know that the quality of the fruits in Indian scenario is not up to the international mark. In the many big cities like Delhi and Mumbai, every marriages, when we see the fruits, the majority fruits are imported. Now in Nasik, they are exporting grapes from Nasik. And the farmers from Nasik like Sahyadri farm, they have their own nurseries. They are selecting the good quality of grape nursery they are using and making it, and by which they increase the productivity. Farmers are doing excellent jobs. Your research is very important. Whatever the research you are doing, I am giving special thanks to you. But as a person, I was always asking one question in agriculture university, that you need 6 Vetan Ayog, 7 Vetan Ayog. Why you need it? What is the financial audit is very important, no doubt. But performance audit is more important than financial audit. I am a representative of government, and that is the reason I will request you that all this research is very important, very good, and people are very capable. But when I am asking you the question whether this research on grassroots level, what are the results? how you are going to implement your research in grassroots level? This is the question in the mind of the common farmer, and you have to answer it. And that is the reason that the expectation of the farmer is very high. And you need to formulate the policy, what is to be need of the country, what is the need of the region, what is the need of the farmer, what is the need of the market. On the basis of that, if we can formulate the policy with the government support, then we can make the success story. I know that you are doing excellent jobs. You are trying your level best. But somewhere with comparison with international scenario, we need to understand what are the development in the USA, what are the development in California, what are the development in Israel, what are the development in Korea. On the basis of that, we need to make the research and study. I'm just giving you the example of automobile industry, which is related with my ministry. When I taken charge as a minister, our automobile industry number was 7 in the world. Today we have the size of the industry is 12,50,000 crore. All reputed brands in the world are present. And now just we surpassed Japan. Our number was 4 and now our number is 3rd. And I am taken as a mission and target to my ministry that we want to make automobile industry in 5 years number 1 in the world. We have got the capability, we have got the potential, we have got the research on ethanol, methanol, biodiesel, bio-LNG, bio-CNG, electric and hydrogen. Now we are making a bio-aviation fuel. So everywhere the research is very important. The innovation, entrepreneurship, science, technology, research, skill and successful practices. We name it as knowledge and conversion of knowledge into wealth in the future. But the one thing is very important, the knowledge and research. It should be implemented on grassroots level. It should be beneficial to the poor people. It should be beneficial to the rural agriculture economy. It should be beneficial to the farmers. So as a public representative and a farmer, I am always asking the question to all research people. I am not insulting them, but I am asking them, what is your practical application of your research on grassroots level? By your research, how the farmer attitude, approach is changed. By your research, how is productivity changed? How is quality changed? Without that, that research is only deposited into safe deposit vault of government, Almari. So it's of no use. It should be useful for the common people, and that is to be the great expectation from all the people. I am really happy that today I am giving my special thanks to Mr. Dilip Ghosh. That first of all, this conference is giving opportunity to Indian people and the people from abroad to understand what are their research, what are their approaches, what are their development. And by creating cooperation, coordination and communication between all the stakeholders, it is going to change qualitative reform in this field. So this conference is going to be useful for giving qualitative reform in this field, not only for India, but for the world. And I am really happy that initiative taken by Dr. Dilip Ghosh and his colleagues, really it is a good contribution from them, in particularly in the field of knowledge. I am giving my special thanks to Mr. Ghosh and his team and all office bearers for organizing this conference. And I am expecting that 3 to 4 days discussion, your seminars, you put up a note. I always, Prime Minister, when giving permission to minister going abroad to officers, he always telling to the people and everybody that you should go and submit your report. And tell the department colleague that what is going to happen, what you are going to do it, what is going to see new thing in the area of particular your field. So on the basis of that, my suggestion and my request to you, that on the basis of that, you and Mr. Sharmaji and Government of India Agriculture Department, you should formulate the appropriate policy of world standard, which is going to helpful in the field of oranges, making good quality of oranges, productivity and disease-free plant, and by which that change is going to helpful for the future. The futuristic vision, futuristic technology, and futuristic planning is very important, and I am expecting that 100% you will do it. Once again, I am giving my thanks to all of you. I am giving my special best wishes to people who have excellent research in this field. I am giving my best wishes to all of them. I also welcome all the people who are brought from South Korea, USA, and for their contribution in this field. I am giving my special wishes to them. And once again, giving thanks and giving best wishes to all of you. I am giving that this conference is also inspired and motivated and giving a futuristic vision in the field of oranges, particularly for the farmer, and which is going to change the scenario in the country. Once again, giving thanks to you. Thank you very much. Namaskar.
Thank you, sir, for your motivational speech, support and blessings. This brings us to the end of our inaugural session. Now I call Organizing Secretary of Asian Citrus Congress 2023, Dr. S.S. Roy, for proposing the vote of thanks.
Thank you, Sangeeta. Respected Chief Guest, Guest of Honor, Convener, other dignitaries on the dais, all invitees, delegates, representatives from print and electronic media, ladies and gentlemen. Thank you is such a prayer which cannot be seen or touched. It must be felt by heart. It's my privilege to have been asked to propose the vote of thanks in this august gathering. First of all, we would like to express our deepest sense of gratitude to our respected Chief Guest, Sri Nitin Gadkari ji, Honorable Minister of Road Transport and Highway Government of India. Despite of his busy schedule, he was kind enough to spare his valuable time to grace this function as Chief Guest. Sir, since launching of the website of Asian Citrus Congress to today's inaugural function, you have provided all sorts of support, guidance and mentorship. Sir, the inaugural ceremony marks the beginning of what promises to be an enlightening and groundbreaking scientific conference. We are deeply grateful to all of you for gracing this occasion with your presence. Your commitment to advancing the citriculture is truly inspiring. We are privileged to have you here. We thank you, sir. Next, I would like to express our sincere gratitude to Dr. Himanshu Pathak, Secretary DEAR and Director General ICR. Though he could not make it to be with us this morning, but he constantly guided and monitored the organization of this event right from the preparatory stage to what you are seeing today. We thank you, sir. I feel honored to extend our heartfelt gratitude to Dr. T.R. Sharma, respected Deputy Director General Crop Science and Horticultural Science, ICR New Delhi, who blessed us with his presence as guest of honor. We thank you, sir, for your elegant presence, constant support and encouragement. We are all inspired by your great insights and thoughts. I must mention our deep sense of appreciation for today's guest of honor, Dr. C.D. Mysar, former Chairman, ASRB New Delhi. Sir is a great source of motivation for us. We always learn from him. We thank you, sir, for your inspiring words and valuable guidance. I'd like to express our sincere thanks to our special guests on the dais, Dr. Rogers, Dr. Song, Dr. Kim, and all the dignitaries sitting of the dais. We are deepest gratitude for your remarkable contribution, your passion for science, and your willingness to engage in a truly global dialogue. Your presence here has made this Congress not only a success but also a vibrant and enriching experience for all of us. We thank you, sir. Now we would like to take this opportunity to place on record our sincere gratitude from the core of our heart to our convener, Dr. Dilip Ghosh, and all the delegates from abroad and all the delegates from our country and all the persons present here. If time is money, you are going to spend millions of us in next 3 days. So thanks for giving me this opportunity. Thank you all very much.
Thank you, sir. I request all of you to kindly rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा। जनगण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Jai Hind, thank you all. Now we will break for high tea for 15 minutes. High tea is arranged at the back side of this hall, but I request all the delegates to, after 15 minutes, to kindly occupy your seats because we will be resuming our special plenary session which we had paused in the morning. So please return after 15 minutes.
माझं तर झालं, तुमचं माहीत नाही. क्या सही था ना मेरा रीजन? क्या धन्यवाद. ऑडियो अच्छा हुआ मेरा दोनों चालू है. अरे टाइम बार पे तो अपन लेते ही है ना, एक लॉक तो कर ही सकते ना. फिर टाइम पे लेते ना, तुम्हारे जैसे कि भूल गए क्या दिन. चलो लॉक मारो फटाफट. आशीष मेरे दोस्त. चालला तो बाहेर नाही. ठीक आहे राजेश भाऊ चालला तो बाहेर, तो नाही म्हणते. कितीला ठीक आहे आता सांग तुला काय पाहिजे. काटा नाही पाहिजे. आशीष भाऊ संतर भेटेंगे आपल्याला. पण असे मोठे पाहिजे आपल्याला. मोठे मारू बॅकअप. काळे बंद कर. हो बॅकअप मार रहा हूँ. काढणार तू काढणार.